Hey. Oh, all right. All right. So let's get started. So we discussed on last time we did the lecture slides, chapter 3. Now we're in the vectors. All right. So vectors is can be challenging to some people. All right. But it's a process, and I'm going to show you that process, and I suggest you follow my process, so that way, if you ever have trouble, I can help you, right? Unless you have taken another physics class and somebody showed you another process, I would imagine my process would probably be the one you use. But anyway, we got 3 vectors here, right? Yay or nay? 3 vectors. What is a vector again? Nobody knows what a vector is? What is it though? It's any physical quantity that has magnitude and direction. I need y'all to start speaking up a little bit more, right? Gotta say it with your chest, like you believe what you're saying. It's called confidence, right? So, what do we know about vectors? What is the thing we know about vectors? Vectors have what? How many components? 2. And what are they? No. Alright, so I'm just letting y'all know. So we about to ramp it up. So I hope y'all taking the time to review your notes and practice this stuff and stay in tune, because that what we did on last Friday, that was a walk in the park. Okay? So I'm not set to travel anymore this semester, so I'm going to be here for the remainder of the semester. So for the remaining chapters, we're going to step it up. 3, 4, 5, and 6. Okay? So I suggest that we pay a little bit more attention and get in tune with what we're doing. All right? Because it's going to get a little bit more hairy right here. All right? So every vector has 2 components, x and y component, right? X and y. So the vectors here are what? Vector A. So this is what I do. I do vector A. That's when I draw A and I draw the arrow on top of it, that says that's a vector. The A with the arrow on top of it, that says that's a vector. Okay? Every vector has x and y component. So I can write vector B and vector C. Right? So let's start with vector A. How we get the x and y components for vector A? This is called a component method, right? So I'm going to show you the graphical method. I'm going to show you that second component method, right? Because we have 2 methods for solving vectors. We have the component method and we have the graphical method. This is the component method. And when I say that again, I might say that. I might say, can you evaluate this resultant vector, A plus B plus C, using the component method? So when I say that, I mean what? You got to do this. Graphical method, I'm going to show you that later. But this is component method. So in component method, we're looking at vector A first, right? So what I do is I like to draw the projections, right? Draw the projections. Remember I told you what the projections are. Those are those dotted lines, right? So if I draw a dotted line from here, from the end of vector A to the x-axis, this distance right here tells me how long vector A goes in what direction. Listen at what I'm asking you. I'm asking you a question. Listen at what I'm asking you. Don't just stare at me to either say, I don't know, or say what it is, or say, I don't know. Just don't stare at me and don't say nothing. What does this projection measure? Right? It measures how far vector A goes in which direction? Huh? Vertically. In the y direction. So this is be the what? What would this be called then? the what component? The y component. Do y'all understand that? Do y'all understand that that component of that vector is telling us how far the vector travels in the y direction? So if I draw another dotted line right here, what does this tell us? What about that x component? Tell us what it is. Tell us the whole sentence. Tell us what is it measuring. How far the vector A goes in the horizontal direction. All right, we got it, folks. We got to do that. We got to start doing that, right? As adults, we got to learn how to speak in complete sentences. Okay, we're gonna have to start learning how to do that. All right, got to say exactly what you mean. Can't just say one word and expect people to know what you're saying. The other words of what you're trying to say, right? So this is called the what? What is this called? The x component. Right? And this is theta, right? So how do I find the y component? If I know this is 44 from here, that's the magnitude of this vector, 44, right? And this is my angle theta, right? So my y component is, so this is the what side? Opposite side, right? So my y component is what? Sine of theta, right? Sine of theta, well, that ain't the y component, but let's just write out the trigonometric identity, right? So I know that what? Sine of theta is equal to what? Y component. My opposite is my y component, right? All over what? 44. Because 44 is the what? Hypotenuse. So if I work backwards, I can get my y component now is 44 sine theta. So as long as I know the value of my angle, I can calculate the y component now. So the y component is 44 sine theta. Now my x component, right? That's this, right? That's the equivalent of this. And this is the what side? Adjacent side. So I know this is what? 44 cosine theta. Right? Because cosine of theta is what? Adjacent side, which is x component, over 44. So therefore, x is equal to what? 44 cosine theta. All right, so now we got our, let me just put write all of them over here. We're getting messy. All right, and so B right? So I go from my tip of my vector and I just draw my projection down to the x-axis, right? And then I draw my projection to the y-axis. I know this is my what? X component. And this is my what? Y component. Now I know that what? And this is theta right here, right? So I know that what? Opposite So I know that what? Y is sine. So I know, and this is what? 32. So I know that what? 32 sine theta. And this is going to be what? 32 cosine theta. 32 cosine theta. The only thing I need to remember here is that because it points left, right? We know that everything in this quadrant is what? Positive and positive. And here is what? Positive and negative. Here is what? Negative and negative, right? And here is what? Negative and positive. So I know my answer here is going to be what? Negative. Y'all following that? Any questions about that? Huh?
Would it not be negative positive because that's the x?
Oh, sorry. Yeah, I got that back. No, this is negative, positive. Sure, you're right. Right. Oh, and this one would be what? This one would be, oh no, negative, positive, right? Is that right?
No, positive.
Oh, yeah. Good. Glad you're paying attention. I make mistakes sometimes too. All right? So now we got to deal with C. Right? And so C, here's our angle, right? So we could say, either we could take this angle right here. We take that angle, right? Just depends on which one they give you in the problem, right? But let's take this angle, and let's say that angle is theta, right? So then what we would do is we would do what? Draw projections. Boom. Boom. See that? Now, for C, vector C, all right? So here, theta, I just do theta 1, theta 1, theta 2, theta 2, theta 1, 2, and 3. So here we got what? So here, this is our what component? Y. Right? So our Y component is, and we know this is to be 15, right? So our Y component is what? 15 sine theta, right? And because it's pointing down, we know it's going to be what? Negative. And here, right, we're going to have what? 15 cosine theta. And because it's pointing left, it's also negative, right? All right. And so now, let's say, so theta 1 is, let's say theta 1 is 33 degrees. Theta 2 is, so from the 33 degrees, so let's say theta 2 is 27 degrees from negative x-axis, right? So if it's 27 degrees from the negative x-axis, then that means what? From the positive x-axis is what? 180 minus 27. Y'all following what I'm saying? This is 180, right? A straight line is 180 degrees. All right? So then, if the problem says, all right, theta 3, right? Theta 3 is, it'll say something like, let's say 25 degrees south or south south 25 degrees south of negative x-axis. Okay? So if it's 25 degrees south, then that means this is 25, so then that, right? So we can use that. We can use either 25 or we can use what? 180 plus 25, and it's gonna give us the correct signs if we do that. If we use 180 plus 25, that's geometry, y'all. Right? That's why I just give you the angles. I'm not expecting you to understand geometry. All right? I'm just showing it to you so if you can pick it up, then you'll see it clearly. All right? So it'll say 25 degrees south of negative x-axis. So now all I gotta do is do what? Plug in the thetas. And I should have all my components. So what are they? A, X, Y, what are they? 44 cosine of 33, 44 sine of 33, make sure your calculator is in degrees. Got to be in degrees. 9 degrees, you're going to get wrong numbers. Y'all don't know how to, y'all got it? Y'all got it? So we got X, Y, and you said you got what? 36.9 and 24. Everybody else got that? Anybody got something different? Did anybody get something? Say what? Got the same thing. So B, what are B? Negative 28.5. Then 14.5. Anybody got anything different? All right. And C. Use 25, right?
Yes.
This
You
should
want
be.
to round up to negative 14?
Huh?
You want me to round up to just like negative 14?
No, just tell me what it was.
Okay, negative 13.5.
Negative 13.5.
And then negative 6.3.
Negative 6.3. Anybody got anything different? All right, so what we've done is we have resolved all of the vectors into their x and y components. Now that makes the remainder of our task very simple now. That's why we had to do that first. So if we don't do this first, then we can easily confuse ourselves. So A plus B plus C, and hopefully y'all got this by now. So how do we? Yeah.
Why the X on B and then?
The X on what? B, because it's pointing to the left. Right? This is negative. According to this, right? This is negative. Going this way is negative. Going this way is positive. So, because the vector pointing that way is negative. Just like here, the vector pointing that way and down. So, both negative. So, now we're going to deal with this, right? A plus B plus C. So, in order to get the resultant vector of A plus B plus C, right? That's a resultant vector. That's a resultant vector, which is the combination of vector A plus vector B plus vector C. Right? So once we have them resolved in this way, it's very simple. Right? So I'll just write it in algebraic form, but in order to do this, we know that each vector has X and Y components, right? So then what we do, this, right? Let me see, how can I write this to make it, oh, okay, yeah, I can write it like this. So this equals this, right? AX plus BX plus CX. That's the X component of vector R plus the Y component from each individual vector. Y'all following what I'm doing? So this is like a little puzzle. This is the Y component of vector R, of the resultant vector, which is the combination of A plus B plus C. So then now I got them all right here. So this is what? AX is 36.9. BX is 28, negative 28.5. CX is negative 13.5. That's all right there. That's my X component of my resultant vector. And now I do my Y component. My Y component is what? 24 plus 14, 14.5 plus negative 6.3. That's my Y component of my resultant vector. So when I add these up together, what do I get here? Somebody tell me. So 20.
All of it?
No,
Or just the X?
just these. These are bracket. What is it? So negative 5.1. That's my X component of my resultant vector. Plus, what's this? 32.2. And that's my Y component of my resultant vector. So every vector has a X and a Y component. So this resultant vector, A plus B plus C, is equal to negative 5.1 X plus 32.2 Y. That's the answer. X and a Y. Unless one of them is 0. And there are cases where that happens, right? So that's A plus B plus C. So now I need you to do A minus B minus C and B minus A plus C. And we're gonna agree or we're gonna disagree. One or the other. But I need y'all to do that individually. And maybe we'll turn that into. Yeah, that's what we'll do. So I'm tired of talking. Shouldn't be too hard though. Did it for you. Now I got a roll going around.
Hey, question.
Yeah.
So you know how the x component of the R vector is plus the y component of the R vector, right? Because they all add.
Wait, hold on. You said the X component of the R vector.
Which is A, B, C.
A plus is the X component of A plus the X component of B plus the X component of C.
Okay, so when I subtract, would I change that middle sign to subtract two? Or is it still add?
No, it's always X plus Y. Yes. Let's do plus the next one. guess I should have said here. I should have put north right here. 27 degrees north. North of negative x-axis. We're not gonna take another, we're gonna use what we did for the last thing, that's your midterm. Alright? But we're gonna, but like next week, we're gonna be taking another exam, so brace yourself. Alright? We gotta pick it up. We gotta at least cover 7 chapters. Remember, right here you see how it's A plus B plus C. So whenever you do this, it has to be just like this. A minus B minus C inside of these brackets. B minus A plus C. So when you do this one, right, it's going to be BX minus AX plus CX. Follow me? Like it's a little puzzle. That's why you do this and get these numbers first. Once you get these numbers, then it's all just a matter of keeping track of what you're doing. Being organized. So the same way we added them up here, you got to do whatever it says to do here, inside here.
Okay, and then for the y,
It would be by, for this one, it would be by minus ay plus cy.
right. But are you adding it to the, or you subtracting?
This is always the same.
That's okay.
This is x component plus y component.
Okay.
But this inside of the brackets, this is this.
Okay.
Following me now?
I am.
Okay. Yeah, if you want to do it next time. Friday.
Check it. Checking them.
Say what?
Checking them.
I'm checking.
Yeah.
Nah, I mean, you should have checked it from here.
I did.
I check them on the test.
Alright.
Yeah. So that's why I did it right here, so you can check it, and so you can know what you did.
Yeah.
Hopefully you can, right? Test is when I check. But I'm gonna give you credit though. Give you credit for turning something in. But you need to make sure you know what you're doing. Because you know that better than I do, right? Alright.
Man, I forgot my water bottle.
Say what?
Nothing, I just forgot my water bottle.
Oh. Alright, I think I can stop this.